Hello there. Welcome to Boring Science for Sleep, a quiet place where gentle curiosity meets bedtime, where the world slows down and science becomes a soft lullaby. If you're here to unwind, to drift, or just to be still for a while, you're in the right place. Before we begin, if you'd like, tell me where you're listening from, and maybe what time it is right now where you are. I always love seeing the little windows into your world. Settle in. Let the lights dim around you. Maybe your body is wrapped in blankets, or your head is resting just right against the pillow. Maybe you're listening with your eyes half closed already, drifting. And somewhere, in the quiet behind your thoughts, is gravity, softly, invisibly, always at work. Gravity has been with you since your very first breath. It pulled you gently toward the ground when you stumbled as a toddler. It held the warm weight of blankets against your legs when you were tucked in at night. It's what keeps your favorite mug on the table and your feet beneath you when you're lost in thought. You may not think of it often. That's part of its magic. It's always there, and it never raises its voice. There's something almost polite about gravity. It doesn't shove, it doesn't demand, it whispers. Not with sound, but with gentle presence. Like a quiet, gloved hand resting on your shoulder, reminding you softly, down is this way. And it's not just here in your room. Gravity connects you to everything. It's the thread that keeps the moon tethered to us, turning ocean tides like the rhythm of a lullaby. It's the hand that sculpts planets, the voice that guides stars through their long journeys. It's the only reason you can look up at the sky and feel awe rather than spinning endlessly through the dark. The thing is, gravity isn't a thing you can hold. You can't scoop it into a jar or point to it on a shelf. But you feel it, constantly. Not as pain or pressure, but as certainty, a quiet, unquestioned downness, a direction for your thoughts to settle, for your bones to rest. Tonight, we'll drift with gravity. We'll explore the curious way it works, not just in facts and figures, but in feelings and metaphors, in the way it shapes your everyday without ever asking to be noticed. We'll meet the thinkers who tried to explain it, the poets who admired it, and the scientists who learned that gravity is not a force at all, but a curve in the stage where reality plays out. We'll listen to gravity's lullaby, the way it tugs at oceans, shapes time, and cradles your body as you fall asleep. You don't have to keep up. Let these thoughts float through you like leaves on water. You don't have to remember any of this. This story isn't a lesson. It's a drift, a weightless exploration of something you've always known, but maybe never truly looked at. And if you fall asleep along the way, then gravity will have done its job. Because in the end, everything falls. Raindrops, apples, eyelids, even thoughts, eventually, settle. Tonight, we begin with a question that's older than language. Why do things fall? Why not drift away? Why not rise? Why is down, down? Before equations or textbooks, humans looked at falling leaves and thought of spirits, or invisible hands pulling things to the earth. They watched birds return to the ground when they stopped flapping. They watched stones fall no matter how gently they were released, always down, and always with the same softness. Gravity, as it turns out, is not just about things falling, it's about everything holding on. It's how you stay on Earth, how the Earth stays in orbit, how the sun holds the planets like a calm conductor guiding a slow-motion dance. There is a kind of grace in gravity, because it never asks for attention. It is quiet, predictable, comforting. And yet the more we studied it, the stranger it became. Over the next little while, minutes or hours depending on whether you stay with me or slip off into sleep, we'll explore that strangeness together. We'll float through history and peek into black holes, drift alongside moons, and wonder what life would be like if gravity ever let go. But for now, there's nowhere you need to be. Just here. Let your shoulders drop a little deeper into the bed. Let gravity hold you, without question, without resistance. You've been held by it your entire life. Let's begin to notice it, slowly, softly, and one falling thought at a time. Before science gave gravity a name, it was just a quiet puzzle, a mystery no one could escape, and yet no one could see. Early humans may have had no word for gravity, but they felt its pull the same way you do now. When they dropped a stone, when they leapt into the air and returned to Earth, when they noticed the way water always flowed downward, not up, they lived by the tug of gravity, long before they ever spoke about it. In some cultures, the pull of the Earth was believed to be the breath of spirits, calling things home. In others, falling wasn't a matter of physics, it was obedience. Objects returned to Earth because it was their place, their destiny. The ground was more than a surface. It was an anchor, a mother, a law written into the world. Imagine someone in a quiet field thousands of years ago, watching a leaf fall from a tree. No numbers, no formulas, just eyes, and the feeling that something invisible had whispered, "Come back!" Ancient Greek philosophers tried to explain it. Aristotle believed that objects had natural places they wanted to reach. Earth, water, air, and fire all sought different directions. Stones fell because their nature was to fall. Smoke rose because it longed for the heavens. Simple, poetic, and deeply human. Because when you don't know how something works, you often ask why it wants to. You treat it like a character, a choice, a story. And that's where wonder begins. Thousands of miles away, in ancient China, thinkers pondered balance and harmony. They noticed how things flowed downward, like streams finding the sea, and how movement was shaped by unseen rhythms. Gravity wasn't a force to them. It was a balance, a settling, a return to stillness. In India, early scholars observed celestial patterns and calculated the movement of stars. They recognized a kind of order, something binding the heavens to motion and motion to the earth. They didn't call it gravity, but they knew something held it all together. There's something comforting about that idea, isn't there? That long before math and machines, people simply, noticed. They didn't need telescopes to feel the earth pulling softly beneath their feet. They just lived by it. They trusted it. And maybe that's the most important thing gravity has always offered. A reason to feel grounded. Of course, none of them had it quite right. Aristotle's theories were elegant but flawed. Stones didn't fall because they wanted to. Smoke didn't rise because it preferred the sky. But these early ideas weren't failures. They were stepping stones, soft invitations to look a little closer. That's how science often begins. Not with an answer, but with a beautifully wrong guess. And while these ancient ideas seem far from your world now, with your clocks and satellites and phones that know where you are, they are still part of the story. Because they show something deeply human. That we've always tried to explain what we feel. That the pull you sense when you drop your keys or watch the moon rise has always been felt. Even when it had no name, gravity was never discovered in a single moment. It revealed itself slowly. In leaves, in rivers, in the heavy thud of a fruit falling to the ground. It whispered before it ever taught. And now here you are, thousands of years later, still living by its rhythm, still wondering about its nature, still feeling its quiet guidance as your head sinks gently into your pillow. In the next part of our quiet journey, we'll meet the man who famously gave gravity a name. Though the story you've heard about an apple and a sudden spark of genius might not be quite what you think. So let's wander softly toward a garden, where a falling apple will become one of science's most iconic metaphors, even if the truth is much more human. But you don't need to hold on to that thought. Let it rest. Like everything else, it will come back down. Let's walk together, softly, into a garden. The year is somewhere around 1666. The air is quiet. The world, still so young in what it knows. And in the middle of this gentle scene, a man sits alone beneath a tree. His name is Isaac Newton. Now, the story goes like this. He saw an apple fall, and suddenly, just like that, he understood gravity. It's a nice image, isn't it? Clean, neat. The tree, the thinker, the fruit of knowledge dropping into his lap. But that's not exactly what happened. There was an apple, yes. But no one thinks it struck his head. And Newton didn't jump up shouting, "Eureka!" or scribble formulas on a napkin. Instead, something far more ordinary happened. He simply noticed. A quiet apple, falling straight down. Not sideways, not drifting, just downward, as it always does. And Newton, sitting in the hush of that garden, began to wonder, what pulls it down? Is it the earth pulling? Or the apple reaching? Or something else entirely? He began to imagine a force, a soft pull between the earth and the apple. And then, like a string being tugged, he imagined the moon. What if the moon, so high above, was also falling, but sideways? What if gravity didn't stop at the treetops? What if it reached all the way into the sky? It was, in many ways, the first time someone had truly asked, what if everything pulls on everything else? Newton's idea was beautifully simple and incredibly bold. Every object in the universe pulls on every other object. The more mass it has, the stronger the pull. The farther apart they are, the weaker that tug becomes. You, the earth, the moon, even this pillow beneath your head, everything tugs, all the time. But you don't feel most of it. Why? Because gravity, like kindness, works best when it's shared quietly by something enormous. The earth is huge, and you're small compared to planets at least. So the earth's pull is strong enough to keep your feet down, your tea in its cup, and your thoughts from drifting too far. Newton called this pull a force, the force of gravity. It was a lovely idea, one that held up for centuries. A neat equation that predicted everything from falling rocks to the orbit of the moon. It told us how fast things would fall, how planets would spin, how tides would rise. And most of all, it gave us a sense of control. The universe was no longer just a stage of mysterious motion. It was a place of rules, softly spoken, but reliable. But even Newton knew something was missing. He didn't know why gravity happened. Only that it did. He described the how, but not the what. He once wrote that one body may act upon another at a distance through a vacuum without the mediation of anything else is to me so great an absurdity that I believe no man can ever fall into it. In simpler words, he didn't believe in action at a distance. He thought there had to be something connecting things, but he couldn't explain what it was. So he left it there, a soft question, unanswered, and the world moved forward with his formulas in hand. Every time you drop something, you're using Newton's ideas. Every time a spacecraft launches, a satellite orbits, or the moonlight glows across the water, Newton is there, quietly in the math. But gravity wasn't finished telling its story. There was still more. Another voice, quiet, patient, waiting to speak. And when it finally did, centuries later, it didn't just adjust Newton's picture. It bent it, literally. In the next segment, we'll meet someone who didn't just describe how gravity pulls, but how it curves. We'll take a quiet stroll across Einstein's soft fabric of space, where time itself bends gently around mass, and gravity becomes not a force, but a shape. But don't worry about that just yet. You're not being tested. You're being held by the same gentle pull that Newton noticed long ago. And by the time we reach Einstein, you'll already be floating there with us, without ever leaving your bed. By the early 1902, Newton's picture of gravity had served us well. Falling apples, orbiting moons, swinging pendulums, all could be predicted with neat, tidy math. And yet, there were small problems. Tiny oddities that didn't quite fit. A wobble in Mercury's orbit. The feeling that something was missing from the way we imagined space itself. And then came a man who didn't just look at gravity. He looked at the stage on which the entire universe was set. His name, of course, was Albert Einstein. And he didn't rewrite Newton's rules. He folded them. Let's picture space, not as an empty nothingness, but as something real, a fabric, soft, stretchable, quiet. Now, imagine placing something heavy on that fabric. A bowling ball, maybe. What happens? The fabric dips. Anything nearby, small marbles or a curious planet, will begin to roll toward that dip. Not because the ball pulls them, but because it has reshaped the space around it. This, Einstein said, is gravity. Not a force, but a curve. Mass, how much stuff something has, tells space how to bend, and space tells everything else how to move. A sun bends space, and planets simply follow the curved path around it. Not because they're being pulled, but because they're obeying the shape of the universe beneath them. It's as if the cosmos were a giant quilt, and every star, every planet, every cell in your body is gently pressing into it, each making a little dip, each affecting the fabric just a little bit. Even you are bending space right now. It's not a dip you can see, and certainly not one you can feel, but it's there, and the Earth is responding to it in its own quiet way. Einstein's view of gravity was strange, beautiful, but strange, because it said that gravity is geometry, a map written not in ink, but in curvature, and it had consequences, huge ones. Time itself, for example, is tied into the fabric of space. They are one thing, space-time, and if space can bend, so can time. That means that gravity affects clocks. A clock on a mountaintop ticks ever so slightly faster than one at sea level. Why? Because it's farther from the Earth's center. It's in a shallower dip, and the deeper you go into a gravitational well, the slower time moves. Let that settle in for a moment. Gravity isn't just holding you to Earth. It's slowing your seconds, shaping your hours. And when you lie down at night, like you are now, you're lying not just on a bed, but in a slow-moving pocket of space-time. You don't feel it, but your atoms know. Your heartbeat knows. Your dreams drift through it without even noticing. Einstein's ideas were proven in time. Literally. In 1919, during a total solar eclipse, astronomers observed light bending around the sun just as Einstein predicted. Not because the light changed its path, but because the space around the sun was curved. Even photons, tiny packets of light, had to follow the dips and folds of the universe. It's a gentle thought, isn't it? That the universe is shaped like fabric, and that we all move across it, not by being pushed or pulled, but by listening to its curves. When you move, you are following the contours of a giant invisible landscape. When you fall, you are not being yanked. You are simply gliding downward into a bend. Falling, in Einstein's view, is what happens when you let go and allow space to show you the way. The planets follow this path. So do stars. So do light beams and comets and you. You don't have to memorize this. Just let the image float. The universe as a great cosmic quilt, bending quietly, softly, under every mass, large or small, and you, resting in one small corner of it, just heavy enough to make a dent of your own. In the next segment, we'll rise from this quilt and drift upward into low-gravity environments, to the moon, to orbit, to places where that familiar pull loosens just a little, and we'll ask, what does gravity feel like when it almost lets go? But for now, You can remain right here, nestled gently in your own little pocket of curved space-time, held softly, just like always. Let's leave the Earth for a little while. Float up, not too fast, just gently, like a slow balloon rising into quiet air. Out here, things feel different. Not weightless, exactly, but lighter. The Earth still tugs at you, just a little less with every mile. Like a parent holding onto the end of a long rope. Still connected, but looser now. Now imagine you're standing on the moon. The ground beneath you is grey and soft. The sky is black, even in daylight. And your body, the same body you live in every day, suddenly feels like a feather. On the moon, gravity is only 1/6 as strong as it is on Earth. That means you can jump higher, fall slower, and carry things that would feel impossible at home. Your bones still press downward. Your boots still make little clouds of dust. But everything moves in a kind of gentle, slow motion. That's what astronauts felt. They bounced instead of walked. They stumbled and laughed. They said it felt like dream walking, not flying, but drifting in rhythm with the moon's quiet pull. It's strange, isn't it? Same body, same laws of physics. But a different planet means a different weight. Not mass. Your mass is the same everywhere. But weight? That's how much gravity holds you. And different worlds hold you differently. On Mars, you'd weigh about 38% of what you weigh here. On Jupiter, if you could stand on its swirling storms, you'd feel more than twice as heavy. And in space, far from any planet's grip, you'd feel nothing at all. But here's the thing. You wouldn't be floating because gravity was gone. It's never gone. Even in orbit, astronauts are still falling. They're just falling sideways. Imagine tossing a ball. If you throw it gently, it arcs and falls. If you throw it faster, it goes farther. Now imagine throwing it so fast that it keeps missing the ground, because the ground keeps curving away beneath it. That's orbit. The International Space Station? It's falling. Always. Endlessly. But it keeps missing the Earth. So the people inside feel weightless, not because gravity disappeared, but because everything is falling together. And that's what weightlessness really is. A shared fall. There's a softness to that idea, isn't there? That when you feel light, it's not because you're free from gravity, but because you're moving with it. Not resisting, just surrendering to the curve. Some scientists call this free fall, but that phrase can feel misleading, because in orbit, you're not tumbling. You're gliding gracefully, in perfect rhythm with the shape of space. And if you've ever felt like you were floating just before sleep, that gentle lurch, that dreamlike drift, maybe that's your brain remembering what it would be like to feel unheld for a moment, not in danger, just looser. Back on Earth, gravity feels stronger, but it also feels familiar. It cradles your organs. It keeps your inner balance. It helps your blood move downward and gives your body something to push against when you rise. In space, without gravity's steady hand, things change. Muscles soften. Bones lose density. Your body forgets what down feels like. That's why astronauts train carefully. Their return to gravity requires a reacquaintance. It's easy to take gravity for granted, but when it fades, you start to notice how much of your life depends on it. Your walking, your heartbeat, even the way your inner ear tells you which way is up. And maybe that's a lesson worth carrying. That even the softest forces shape the strongest parts of you. In the next segment, we'll return to Earth, but not to your body, to your blood, bones, balance, and breath. We'll explore the hidden ways gravity shapes you, from the way you stand to the way your brain stays inside your skull. Gravity is not just something that holds you down, it builds you. But for now, just imagine this. You, floating above the Earth, curving gently around it, in a fall that never ends, with no need to land, just moving, just drifting, held by nothing but motion and space itself. You might not think about gravity much, but it's been thinking about you since the moment you were born. Your body is a sculpture, shaped over millions of years, refined by quiet pressure, chiseled by downward pull. You are built not just to survive on Earth, but to thrive in its gravity. Your spine curves the way it does, to balance you upright against the tug of the ground. Your feet are broad and flat, not because it looks nice, but because Earth's pull needs a stable foundation. Even the fluid in your ears knows how to shift and swirl, so that when you tilt your head, your brain knows which way is down. All of this just to live in harmony with a force you can't see. Your muscles know gravity. They push against it every time you stand, stretch, climb, or carry. You don't just lift things up, you lift them away from Earth's pull. Even lying in bed right now, your body is working just enough to hold its shape against the planet's quiet embrace. Your bones know gravity too. They are denser in Earth's gravity than they would be in space. Astronauts lose bone mass the longer they drift, not because they're sick, but because their bodies are adapting to a world where weight has gone quiet. On Earth, gravity reminds your bones that strength is needed, so they grow, thicken, hold. Even your heart listens to gravity. It pumps harder to move blood upward against the pull to keep your brain awake and alert. Without gravity's soft challenge, your heart gets a little lazy. In space, blood pools in the upper body and faces puff slightly, as if gravity had let go of its end of the seesaw. And what about your lungs? They breathe with ease, not just because of air, but because of pressure. Gravity helps compress your lungs when you exhale. It helps draw them open when you breathe in again. Even digestion listens to gravity. Food moves downward, not just because of muscle contractions, but because gravity gives it direction. Your whole body is a partnership. You move through gravity, and gravity shapes how you move. Now imagine you were raised in space. No weight, no down, no pressure on your feet, no reason for your bones to strengthen or your heart to work so hard. Your body would become something different. Not wrong, just adapted to a softer world. And then, if you came back to Earth, even for a single day, you'd feel the weight of everything, the pressure on your joints, the resistance in every movement, the presence of a force you once took for granted. Gravity isn't loud, but it is constant, persistent, kind, in a way that consistency can be. It gives you something to press against, and in pressing, you grow. Even your posture is shaped by gravity. If you slouch, gravity pulls more harshly. If you align your spine, gravity distributes more gently. It rewards balance. It discourages collapse. And it does all of this without scolding, without praise, just presence. You've spent your whole life working with gravity. Even now, as you lie still, it's shaping your rest. Your mattress holds you, yes, but what gives it purpose is gravity's pull beneath it. The way your blanket rests against your skin, soft, weighted, is not just fabric, it's gravity's embrace. It's strange to think about, isn't it? That every step you've ever taken has been a small, negotiated rebellion against gravity. But every time you stopped, it caught you. In the next segment, we'll rise beyond the personal and drift into the graceful curves of planets and moons. We'll step back to watch the solar system dance, held together by gravity's quiet choreography. But for now, just notice your body, the way your hands rest, the angle of your jaw, the weight of your breath. none of it would be what it is. Without the planet beneath you, pulling gently, always. If you could step outside the solar system for a moment, just far enough to see the whole thing, you'd witness a dance. Not frantic, not wild, but slow, steady, predictable. A circle here, an ellipse there, a planet spinning like a skater, all while moving forward in its quiet lane. It would look choreographed, as if someone had set the planets in motion with a soft push and trusted them to keep going. But no one is pushing. There are no invisible strings. There is only gravity, tugging, balancing, keeping everything from flying off into the dark. The sun is the anchor. It holds 99.8% of the mass in the solar system. It's massive enough, in fact, to bend space so deeply that all the planets around it simply follow the curve. Imagine a coin rolling around a bowl. It loops and loops, not because the bowl grabs it, but because the curve guides its path. That's what orbit island. Not a leash, just a path of least resistance. Mercury twirls fast and close, a tight, quick spin. Venus and Earth follow in more graceful, balanced loops. Mars dances a little farther out, red and watchful. And then come the gas giants. Jupiter, Saturn, Uranus, Neptune. Slow dancers, moving with the patience of centuries. Each planet is held by gravity. Each is also pulling, subtly, on everything else. It's not a one-way relationship. Even Earth, small as it is, tugs ever so slightly on the Sunday. It's all mutual, all balanced. A gravitational conversation that's been happening for billions of years. Moons join the waltz, each one bound to its planet, spinning, orbiting, following not just the planet's gravity, but the sun's too. It's a dance within a dance, a waltz within a larger symphony. And it's not just bodies that follow these curves. Rings of Saturn, clouds of comets, fields of asteroids, all in orbit, all held in place by gravity's silent, persistent hand. Sometimes, things collide. A comet veers too close. An asteroid drifts inward. Even planets can be nudged, ever so slightly, by the pull of a neighbor. But for the most part, this is a system of peace, of balance, of long, slow arcs through space. And it's not just beautiful, it's essential. Without gravity, the planets would fly off in straight lines. The moon would drift away. The tides would stop. Seasons would vanish. Life, as you know it, would unravel. But because of gravity, you have calendars, sunrises, equinoxes, predictable orbits that mark the passage of time and shape the rhythm of life. All of this happening far above you, and yet directly connected to your daily experience. Because gravity doesn't just hold planets, it holds meaning. There's a softness to this, isn't there? That you are part of a system where balance is maintained not by force, but by quiet motion, where even the largest objects in the universe agree to move in circles, forever falling without ever crashing. If you've ever watched a mobile spin above a crib, you've seen a tiny version of this dance. Each piece suspended, turning, held not by glue or wire, but by balance. Now imagine that same dance, but with planets. In the next segment, we'll bring our gaze back to Earth and to its oceans. We'll explore how the moon's gentle tug, combined with the sun's distant hand, lifts and lowers the seas, twice a day, every day, for billions of years. But for now, picture it, the solar system, not as a machine, but as a music box, and gravity as the song that every planet knows by heart. Twice a day, every day, the oceans rise and fall, sometimes subtly, sometimes dramatically, but always in rhythm, as if Earth itself is breathing, inhaling, exhaling, with a cadence guided by something far above. That something is the moon. Soft, pale, silent, hanging in the sky like a glowing coin. But don't let its quiet fool you. The moon may be small compared to the sun, but it has a gift the sun doesn't share. It's close, and in gravity, closeness matters. The moon's gravity pulls on Earth's oceans, not all at once, not in great sloshing waves, but slowly, gently, like a hand on the edge of a blanket, pulling just enough to make it shift. Water, being fluid and free, responds easily. It gathers in a bulge on the side of Earth facing the moon, as if reaching for it. But here's the strange part. There's a second bulge, on the opposite side of the Earth. How can that be? Well, while the moon pulls on the near side, the Earth itself is pulled more than the water on the far side. So that water lags behind, stretching away in the other direction. Two bulges, two tides. High tide where water reaches, low tide where it retreats. And because the Earth rotates beneath these bulges, coastlines experience the rising and falling water as a daily rhythm. It's not instant. The ocean has inertia. It lags behind slightly, which is why tides aren't perfectly aligned with the moon overhead. But the cycle continues, reliable as a heartbeat. The sun plays a role too. Though it's much farther away, its massive gravity also tugs on the oceans. When the moon and sun align, during new and full moons, their pulls combine. These are spring tides, higher highs, lower lows. When the moon and sun are at right angles, they work against each other. These are neap tides, gentler, subtler, but no matter the phase, the moon is always at work, pulling, lifting, lowering, shaping. Tides affect more than boats and beaches. They sculpt coastlines, feed ecosystems, guide migrations. Entire species like crabs, fish, and seabirds live by the moon's rhythm. Their clocks set not by sunrise, but by tide. Even humans, long ago, built their lives around tides. Fishermen timed their journeys. Harvesters gathered seaweed and salt. Sailors waited for the water to rise. And in some parts of the world, they still do. You might not live by the sea. You may rarely think about the tide. But it's there, pulling, changing, receding, a whisper from the moon, felt across thousands of miles. And here's something lovely. The moon is slowly drifting away from us, about 3.8 centimeters a year. It's not much, but over millions of years, it adds up. As the moon drifts, the tides will change. Their rhythm will soften. Someday, long after you and I are gone, the Earth's spin and the moon's orbit will sink, and the tides will settle into a slower, quieter dance. Until then, they keep moving. Right now, somewhere on Earth, a wave is cresting. A beach is being kissed by water. A harbour is gently rocking with the moon's pull. It's a reminder that even from far away, gravity can reach, can shape, can touch. In the next segment, we'll drift toward gravity's most mysterious expression, the black hole, where gravity speaks, not in whispers, but in silence, in finality. But for now, rest with this thought. The moon, small and silent, can move oceans. Imagine what you could move just by showing up, just by staying near, just by pulling gently at the world around you. Gravity is usually kind. It tucks you in. It keeps your feet on the floor. It makes apples fall, tides rise, and planets dance. But sometimes, it doesn't whisper. It roars. Somewhere out there, beyond where telescopes can clearly see, In the dark corners of space, gravity folds in on itself, and what remains is a black hole. Despite the name, black holes aren't holes. They're not gaps in the universe. They're not tunnels or traps or magic tricks. They are objects. Real, physical, just different. A black hole begins when a massive star, many times the size of our sun, reaches the end of its life. It collapses. Inward. No more outward pressure from fusion. Nothing left to fight gravity's steady pull. So the star gives in. It falls into itself. The result is dense. Unimaginably dense. So much mass packed into such a small space that even light, the fastest thing in the universe, can't escape. That's why it's black. Not because it absorbs everything, but because nothing, not even light, can outrun its pull. But it's not a vacuum cleaner, not a space monster. A black hole doesn't go hunting. If our sun were replaced with a black hole of the same mass, which, don't worry, it won't be, Earth would continue orbiting exactly as before. We wouldn't be sucked in. We'd just be cold. Black holes are gravity, concentrated. Gravity turned inward. Focused. Final. The point of no return around a black hole is called the event horizon. Cross that line, and there's no way out. Not because of a wall or a trap, but because the curve of space-time becomes too steep. Imagine rolling a marble down a slope. The steeper the slope, the faster the marble rolls. At some point, it's not just rolling. It's falling in a way that can't be undone. That's what the event horizon island. And beyond that, we don't really know. Our physics breaks down. Equations stop working. Time may stretch. Space may fold. Maybe there's a singularity, a point of infinite density. Maybe not. It's one of the few places in the universe where our best guesses go quiet. And yet, black holes aren't just endings. They're also beginnings. They shape galaxies. They anchor star systems. At the center of the Milky Way, there is a supermassive black hole, millions of times the mass of the Sunday. And yet, it's quiet. Sleeping. Holding. Just there. Guiding stars into orbits. Helping define the shape of the galaxy itself. It's strange, isn't it? That something invisible can define the visible world. That silence can shape sound. That something you can't see can give structure to what you do. And black holes aren't completely invisible anymore. In 2019, scientists released an image, not of a black hole itself, but of the light around one. A glowing ring, a shadow in the middle, like an eye in space. It was blurry, beautiful, quiet. The kind of picture that doesn't shout, but hums. Proof that gravity, at its most extreme, still follows rules. Still leaves footprints. Black holes don't defy gravity. They are gravity, turned all the way up. And yet, here's a curious truth. Black holes may be the most terrifying objects in the universe, but you're in no danger. They're far away. They're stable. And they show us just how strange and flexible gravity can be. From pulling on oceans, to shaping time, to collapsing stars into silence. Gravity does not play one role. It plays them all. Soft, strong, strange. In the final part of our journey, we'll zoom back out. We'll look at gravity not as force, or math, or mystery, but as connection. We'll reflect on how gravity isn't just what keeps things together. It is togetherness. But for now, rest with this thought. The same force that holds you to the earth, that presses your pillow gently against your face, is the same one that holds galaxies in shape and stars in orbit. It doesn't matter how big or how small. Gravity is there, everywhere, always. Take a breath. not because you need one, but because you're allowed to, held here, softly, by a force that never stops holding. Gravity has always been with you, from your first step to your last rest, from the sky above to the bones within. It doesn't care who you are, what you've done, or where you're going. It simply includes you. It makes no demands. It does not exclude. It does not forget. Everything that has mass belongs, and everything that belongs is held. That's the quiet truth of gravity. It is, at its core, a reminder. You are part of something, not because you earn it, not because you deserve it, but because you're here, and that's enough. Gravity is what pulls rivers to the sea. It's what tells apples when to fall. It's what makes moons follow planets, and planets follow stars, and stars swirl around galaxies like grains in a cosmic tide. It's the reason Earth has a shape, why oceans have a surface, why feet have meaning. It's why you can rest, why your body fits into a bed, why blankets feel heavy in the best way, why the floor is always there when you need it. And when you feel unmoored, when life becomes too fast, too loud, too disconnected, gravity remains. It never leaves. Even when you're floating in worry or drifting through sleep, gravity is still cradling you, gently, patiently, without needing thanks. It's not just science. It's presence. And maybe, in some quiet way, it's a kind of love. Love is a strange word in science. It doesn't fit in equations. It doesn't appear in graphs. But gravity behaves like love in some ways. It connects. It persists. It draws near, no matter the distance. It doesn't shout. It doesn't demand. It just pulls. Softly. Always. Toward togetherness. And if that's all it does, if all gravity offers is a way for things to be close, maybe that's enough. Maybe that's everything. As you drift off tonight, whether you're still awake or already floating in dreams, remember this. You are not separate from the world. You are held by it, firmly yet gently, unseen yet constant, falling yet supported. Always. Let's start with something strange. Right now, this very second, you are falling. You're just falling very slowly and sideways, and together with the entire planet. That might sound dramatic, but it's true. You are falling through space. So is your chair, your pillow, your building, your trees, your cat, all of it. You're just falling with the earth, not off of it. And that difference, that shared motion, is why you feel like you're standing still. Imagine riding in an elevator that's broken all its cables. It's plummeting downward. But inside, if everything falls together, you might feel light, weightless even. That's microgravity. It's not zero gravity. It's just the illusion of no gravity. Because you and everything around you are falling together. It's why astronauts look like they're floating. They're not defying gravity. They're simply not resisting it. And strangely enough, you feel this too. Sometimes, have you ever been on a roller coaster? Right at the peak, when the car drops and your stomach lifts? That brief float, that tiny rise in your gut? That's gravity letting you fall a little faster than your body was ready for. That's microgravity, here on Earth. Or maybe you've tripped, and for a split second, before you hit the ground, there's a feeling of suspension, your body unheld. A moment where gravity stops pulling and starts catching. In those moments, you realize just how deeply gravity lives in your body. Not just in the way you move, but in the way you expect to move. Even your sense of balance is built on gravity. Tiny crystals in your inner ear sit in gel-like fluid, pressing against hairs that help your brain figure out. Up, down, tilt, spin. In microgravity, those crystals don't settle, and suddenly, astronauts can't tell which way is up. They lose their sense of orientation, not because their eyes are closed, but because gravity's anchor has gone missing. For the first few days in space, many astronauts feel dizzy, nauseated, even emotionally disoriented. Not because space is scary, but because their bodies have never known a world without down. Some astronauts even dream differently. Their limbs float. Their subconscious no longer draws a flaw into its dreamscape. They drift in sleep, then drift awake, both literally and psychologically. But gravity doesn't vanish in space. It's everywhere. It just gets subtle, stretched, shared across vast distances. Even the International Space Station, where astronauts float, is still being held by Earth's gravity. It's just falling sideways, perfectly, continuously, in orbit. This idea that free fall can feel like stillness is one of gravity's most delightful contradictions. On Earth, your body has adapted to resist gravity constantly. Your legs push against it. Your neck supports your head like a carefully balanced sculpture. But in microgravity, that pressure is gone and your body begins to change. Your spine stretches. Many astronauts come back taller, sometimes by as much as 2 inches. Without gravity compressing the discs between vertebrae, your body unfolds like a sleeping flower. But that's not always good news. Muscles weaken, bones thin, even hearts shrink a little, because they don't have to pump blood upward against Earth's pull. That's why astronauts train so hard before and during space missions. They use resistance bands and treadmills with bungee cords, not just for strength, but for survival. Because gravity is more than an external force, it's a sculptor. Take it away, and the sculpture softens. And yet, this softness, this moment of freedom from the ever-present pull, can be deeply meditative. Astronauts often describe a sense of emotional clarity, a new relationship with motion, even a profound shift in perspective. There's a name for this: the overview effect. When astronauts look back at Earth, that bright blue marble suspended in black, they feel awe, not fear, not detachment, but connection, because in that floating silence, they realize something. Gravity doesn't just hold your body. It holds your home, every tree you've seen, every city you've visited, every person you've ever met, all of it, falling together, held together. That's gravity too. And maybe that's why, even here on Earth, you sometimes dream of flying, of floating, of letting go, because somewhere inside, you've always wondered what life feels like, without gravity's hand resting gently on your shoulder. But even when you drift in dreams, gravity is still there, waiting, welcoming you back, ready to hold you again. It never left, and neither did you. You may think that when you fall asleep, the world goes quiet, but gravity never sleeps. It doesn't pause while you rest. It doesn't lift while you dream. It's always there, patient, present, and somehow it plays a role even in your sleep. Let's begin with the brain. At night, while your limbs grow still and your breath settles into rhythm, your brain becomes more active, cycling through waves of sleep, like phases of the moon. There are 4 main stages: light sleep, deep sleep, and REM, where dreams flicker like fireflies across your mind. And through all of it, gravity is gently guiding the experience. You see, your body position matters, and gravity, being what it is, shapes every position you can choose. When you lie on your back, blood flows differently than when you lie on your side. Your heart pumps against less resistance. Your breathing deepens. Even your cerebrospinal fluid, the clear liquid that cushions your brain, shifts slightly, influenced by posture and pull. Gravity redistributes pressure inside your skull, not dramatically, just enough to subtly affect how your brain cleans itself. That's right, your brain has a cleaning cycle. During deep sleep, your brain's glymphatic system activates, a kind of nightly rinse. Toxins and waste products from the day are flushed away by that fluid, and gravity plays a quiet role in determining how well it flows. Studies show that sleeping on your side may allow better drainage, thanks in part to how gravity shapes the pathways in your neck and spine. It's not conclusive, but the suggestion is poetic. Gravity, even now, may be helping you clear your mind. Then there's REM sleep, where your dreams unfold. This is when your body becomes nearly paralyzed. A safety feature. You don't want to act out your dreams, so your brain sends signals to soften muscle tone and let your mind float without your body following. But what is it exactly that your mind floats in? Is it just memory? Is it randomness? Or is it something structured? Some believe dreams are fragments of the day, stitched together like a patchwork quilt. Others think they're simulations, little rehearsals for future events. And still others see dreams as poetic nonsense, the brain playing while no one's watching. Whatever dreams are, they occur in a body still bound to earth, still held by gravity. Even if your mind soars, your lungs still rise and fall. Your blood still circulates. Your body still rests downward. Have you ever dreamt of falling? That lurching drop? That sudden awakening? Heart racing? That's gravity too. Or rather, it's your brain misfiring as it lets go. A hypnic jerk, they call it. A moment where the brain feels the body slipping and sends a sharp signal to snap you back into awareness. It's a glitch, a tug, a reminder. Gravity is still here. You're not floating away. You're safe. And what about memory? That long thread of you, woven from moments, feelings, faces. Sleep, especially deep sleep, is when memories settle. Your brain consolidates. It moves data from short-term to long-term storage, files away the day. And here again, posture, pressure, flow, all influenced by gravity, may shape how well that process happens. It's subtle, but beautiful, because it means that your dreams, your memories, your very sense of self are being shaped, night after night, by something as simple as lying down on Earth. Now imagine sleeping in space. No gravity, no pressure, no up or down. Astronauts float in sleeping bags, strapped to walls or rails. No pillow beneath their head, no mattress beneath their back. Just air and motion. Some report deeper sleep, others struggle. The lack of pressure can make it hard to fully relax. Some miss the weight of blankets, the feel of being pressed into place. That's gravity too, not as force, but as comfort. Even your circadian rhythm, your internal clock, is linked in part to gravity's patterns. Not directly, but through the way Earth rotates. The cycle of light and dark, of sunrise and moonlight, is made possible by Earth's spin, which is held in check by gravity. If the Earth spun faster, days would be shorter. If slower, longer. But as it is, 24 hours, more or less. Your body has learned to sync to this rhythm, thanks to the sun's pull, the moon's tug, the gravitational balance of the solar system. Even time itself, as Einstein reminded us, is shaped by gravity. And since sleep happens in time, it too is bent, stretched, guided. So tonight, as your body lies heavy in bed, as your mind begins to drift, as memories fade into dreamscapes, remember that you're still connected, not just to the bed, or the room, or the planet, but to the laws of motion, to the dance of tides, to the steady drumbeat of orbits and pulls. You are sleeping, inside a gravitational lullaby, held gently, softly, faithfully. We'll leave the body behind and think about identity on a planetary scale. What if you were born somewhere else? Would gravity change not just how you move, but who you are? You've made it all the way here, through apple trees and black holes, through oceans rising, planets dancing, and the quiet geometry of space-time. But you don't need to remember it all. In fact, you don't need to remember anything. This wasn't a lesson. It was a drift. And if somewhere along the way, your thoughts wandered, or your eyes closed, or your breathing slowed, that's exactly what was supposed to happen. You weren't meant to focus. You weren't meant to solve or study. You were meant to feel the shape of gravity in the background of your body, to notice what's always been there. Tonight, as you lie here, as the blanket presses lightly against your legs, as your head sinks deeper into the pillow, as the air around you settles into stillness, remember, this too is gravity. It's not just pulling planets. It's pulling you, not downward, but inward, toward rest, toward peace, toward sleep. There's nothing more you need to do. You don't need to review or repeat. You don't even need to say goodbye, because gravity doesn't go away. It will be here, softly, long after you drift off. Let your thoughts fall like leaves. Let your breath slow like tides. Let your body become heavy, and then lighter, and then gone. You are part of this world, not just walking on it, but held by it, included in its curves, supported by its laws, cradled by its quiet. And maybe, just maybe, that's all you need tonight. To know that even in the silence, you belong. Even in sleep, you are known. Even in stillness, you are moving with everything else, together, always. So let gravity pull. Let it hold what you no longer need to carry. Let it carry you, gently, into sleep. Good night, from this planet, this body, this quiet little corner of the cosmos, and from the invisible hand that's always holding you. you.